Problem is Chapter 5, Review, number 2. The problem asks you to take the function f of x equals x squared minus x and take a look at it on the interval from 0 to 2 to estimate the value of the definite integral by using Riemann sum with 4 subintervals and using the sample points to be the right endpoints of each interval. Since we have the interval from 0 to 2 with 4 subintervals, 4 rectangles if you want to think of it that way, we know that our delta x in this case, or the width of each rectangle, is going to be found by taking 2 minus 0, the width of the interval, divided by 4, the number of subintervals. So that gives us a width of 1/2. Our subintervals then will end at 1/2, 1, 1.5, and 2. Since we're asked to take the right-hand end of the interval, here's interval number 1. If I take the right-hand end of that interval and use that to determine the height of a rectangle, there's my first rectangle. My second rectangle, its right-hand end is a y value of 0, so that rectangle is going to have a height of 0. The third rectangle coming over to the right-hand end of the third subinterval gives me a rectangle like that, and the fourth will give me a rectangle like that. Notice that 2 of the intervals are actually, the first interval has a height. We'll put height in quotation marks. It has a height that's negative. So the values that I'm interested in here, the x values of interest, are 1/2, 1, 3/2, and 2. The heights of my rectangles at those values will be the f of x values at those locations. So we have 1/2 squared is 1/4 minus 1/2. The first interval gives a function value of negative 1/4. 1, as we already mentioned, 1 squared minus 1 gives me a value of 0. 3/2 squared, 9/4, minus 3/2. 3/2 is 6/4, so that leaves me with 3/4 for that height. And finally at 2, 2 squared is 4, minus 2 gives me a value of 2. You'll recall that the Riemann sum, if I call that, we'll call it capital R for the Riemann sum. We know that in this case the Riemann sum is going to have to do with adding up heights times widths for 4 rectangles, and in each case we're going to have some f of x sub I, which simply means the value of the function at the appropriate x value in that particular rectangle, so that's x sub I, times your delta x. Now I could do height times width, height times width, height times width. I'm going to save a little bit of time. I'm going to add the heights together, negative 1/4 plus 0 plus 3/4 plus 2, and I'm going to multiply the sum by the width of each interval, the delta x, which we've already determined is a value 1/2. So here we get 3/4 minus 1/4 is 1/2. 1/2 plus 2 is 2.5. Half times 2.5 gives me 1 1/4, or 1.25 for the value of the Riemann sum. And this is an estimate of the value of the definite integral from 0 to 2 of f of x dx.